Assalamualaikum and hi, my name is Isma'Izz bin Azizan. My license number is 01 23F1005, and in this video I will give you a presentation about generic skill 2 semiconductor devices from end of chapter 3. Yeah, still the same, we'll move to the question that I choose. The question that I choose is question 2A. Common emitter configuration is shown in figure 1A. If the transistor BC107 used in the circuit is silicon type and beta is 200, calculate IB, ICQ, VCEQ, IC saturation and VCE cutoff. But in this figure, in the picture, you can see that there are two RB, so we need to totalize them first. So RB1 plus with RB2, so RB1 plus with RB2, 2k ohm plus with 100k ohm, we get 602k ohms. Then we straightforward to find the IB. So since the circuit is common emitter, so we know that the input terminal is at base and output terminal at collector. Then we can start to find the IB value. So input loop sigma EMF is equal to sigma V drop. So based on the circuit, it starts with VCC. So VCC is equal to VRB total plus with VBE plus with VRE. And then we need to change the VRB total to IB multiply with RB total and plus with VBE, and then plus with IE multiply with RE. And then for your information, IE in IB pronunciation is IE equal to IB plus IC, and for and I think you know that IC is equal to IB multiplied with beta, and we just put the IC equation to the IB, and it will be IE is equal to IB multiplied with 1 plus beta. Next, then we continue to finish our derivation. So VCC is equal to IB RB total plus with VBE plus with IB multiplied with 1 plus beta and RE. And then we move the IB equation to the left and VCC to the right. So IB RB total plus with IB multiply 1 plus beta RE and equal to VCC minus with VBE. And then we need to make the derivation more smaller. So IB is multiply with RB total plus 1 plus beta and multiply with RE also. Then move so we want to find the IB, and then we need to move back the RB total plus with 1 plus beta RE to the right, and it will be divide. So we put the data. We know the VCC is 2 volt minus with 0.7, it will be 19.3 volt, and divide with 602 kilo ohm plus with 201 and multiply with 200. So the IB value is 30.04 microampere. We also can find the IC or ICQ. So IC is equal to beta multiply with IB. So beta is 200 and IB we already get it, which is 30.04 micro, and you multiply them, you will get 6 milliampere. So next, to find the output loop or VCEQ value, still the same, but output terminal is collector, so you need to use the RC value. So VCC is equal to VRC plus VCE plus VRE, and then change the VRC to IC multiply with RC and plus VCE plus IE RE. But at here, for your information, IC is equal to IE. So so we change the IE to IC. So VCC is equal to ICRC plus VCE plus ICRE. And then you need to combine the IC. So it will be IC is multiplied with RC plus RE and plus also with VCE. Okay, so since the question is to find VCE2, so you move the VCE to the left and this VC to the right. So VCC will minus with IC multiply with RC plus RE. So finally we just put the data that given from the circuit, from the figure. So VCC is 20 minus with 6 milliampere and minus with 2200 ohms. So you will get 6.8 volt for VCE2. Okay, second last question is to find IC saturation. So IC saturation, VCE is equal to 0 volt. So we use the VCE2 latest equation. VCE is equal to VCC minus with IC multiplied with RC plus RE. So we change the VCE value to 0. So it will be 0 equal to VCC minus with IC multiply RC RE. Then you move the negative IC to the left, and then it will be IC multiply with RC plus RE and equal to VCC. And the last thing is you need to move the RC to RC plus RE to the right. So the final derivation is VCC divided with RC plus RE, and then 20 divided with 2200 ohms, you will get 9.1 milliampere. And then lastly, to find VCE cutoff is IC is equal to 0. So it's easy question. So VCE is equal to VCC minus VIC multiplied with RC plus RE, and IC you change it the value given, I mean the 0, so it will be, and the last thing left is VCE is equal to VCC. So VCC is 20, and then VCE cutoff is 20 volt also. So that's all. Thank you.